Find the area of the surface obtained by rotating the curve y equals x cubed over 3 between 0 and 1 about the x-axis. So the curve between 0 and 1, we'll say, looks like that. And we're going to rotate this about the x-axis. And end up with another guy down here. We'll have this horn type shape, and we're interested in the surface area obtained by doing that. Well, the formula for surface area is that we take 2 pi, the integral from A to B, the radius times ds. Now ds is the piece of arc length that's obtained. Here's a typical rectangle, and we're talking about this infinitesimally small piece of arc length here. And so that's found by doing the square root of 1 plus y prime squared. Now when you're in terms of x, the radius is that distance up from your axis of rotation. So in this case, we have a radius of y if we're rotating around the x-axis. And we have a choice about how this is done. If we do it as y is a function of x, which is given to us, then it sets up this way, where the integral, in this case from 0 to 1, we have to replace y by f of x, because this integral is going to be a dx integral. And so f of x being x cubed over 3, and ds being the square root of 1 plus that derivative of that guy squared. So we have ds is here, and y is there. This is a dx integral. So if y is x cubed over 3, then y prime is just x squared. Y prime squared is x to the 4th. So we have 2 pi, the integral from 0 to 1, x cubed over 3, the square root of 1 plus x to the 4th. Let's call it 2 pi over 3, the integral from 0 to 1, x cubed, the square root of 1 plus x to the 4th dx. And conveniently, these powers differ by 1. The derivative of the inside is at least some multiple of the outside. If we were to let u be the entire inside, then the derivative of that is 4x cubed, so that we can just divide by 4 and have 1/4 du replace x cubed dx. Giving us 1/4 the integral of u to the half du, giving us 1/4 2/3 u to the 3/2, and so that translates back. These cancel. The 2 becomes a 1, and 4 becomes a 2, and so it ends up as 1/6 u to the 3/2. So now going back, we have 2 pi over 3. And now we have 1/6 1 plus x to the 4th to the 3/2 power evaluated from 0 to 1. 6 can become a 3, 2 can become a 1, and so we have pi over 9. Plugging a 1 in, we get 2 to 3/2. Plugging a 0 in, we get 1 to the 3/2 officially. Okay, and yeah, nothing else we can really do with that. If you want, you can say that it's pi over 9 2 root 2 minus 1. Great.